In example 5, we're going to do the flip. We're going to convert each angle in radians to degrees, and we're going to express the answer in decimal form rounded to 2 decimal places. Okay, so in part A, the angle is pi over 6 radians. Okay, we are going to convert this over to a degree measure. Okay, so we are going to take pi over 6, we're starting in radians. Okay, we are going to multiply by our conversion factor. Okay, you can either flip back to the previous page and pull up the conversion factor, but again, that requires you to memorize that conversion factor. Okay, so just kind of reason through it. Okay, you're trying to convert this to degrees, so you want radians to go away. Okay, so since you have radians in the numerator here, because this, you've got pi over 6, that is a fraction, but units are understood to be in the top here. Okay, and you're going to multiply by your conversion factor. It's going to be a fraction, so you're going to put radians in the bottom because you want radians in the top, radians in the bottom. You want them to cancel and leave you with degrees, so degrees will go in the top. Okay, when you're multiplying by your conversion factor is going to be a fraction, but that fraction needs to be equivalent to 1. Okay, you don't want to change the original problem. Your original angle has to stay pi over 6. So whatever's in the top of the fraction has to be the same as what's in the bottom. Okay, we know that 180 degrees is the same quantity as pi radians. Okay, so what's in the top is the same as what's in the bottom, so anything divided by itself is 1, so this conversion factor is really 1. It's not changing the original pi over 6. Okay, so now we just simplify. Okay, we've got radians in the top, radians in the bottom, they cancel out. We will be left with degrees. Okay, another thing you should notice here, okay, the pi's cancel. Okay, because now, like, you've got two fractions, you've got pi divided by 6 and then times 180 over pi. There is a pi in the top and a pi in the bottom. Okay, they cancel. Okay, so we are just left with 180 degrees divided by 6, okay, and you can simplify this. This is going to be 30 degrees. Okay, so you don't even have to do a decimal approximation there because pi over 6 is exactly 30 degrees. Okay, let's try the next one. Okay, so now we're dealing with 3 pi over 2 radians. Okay, we want radians to go away, so in your conversion factor you're going to put radians in the denominator. Okay, radians in the top over radians in the bottom will cancel. You want to be left with degrees, that will go in the top. Okay, your conversion factor has to be equal to 1. Okay, so whatever's in that fraction, the numerator has to equal the denominator. Okay, so we know that 180 degrees is the same thing as pi radians. Okay, again, if you flip back to your conversion factor on the previous page, okay, that's right here where you're converting from radians to degrees. Okay, you're going to be multiplying by 180 over pi. Okay, that's what we did over here. Okay, but it's a lot more sensible to kind of reason through it. Okay, our conversion factor is 180 over pi. Okay, all right, so now you're just multiplying fractions. Okay, you've got radians in the top, radians in the bottom, they cancel out. You also have pi in the top and pi in the bottom, they cancel out. Okay, and so now you can just multiply here. So if we do this, this is going to be 3 times 180 over 2. Okay, so we can go pop that in the calculator and figure out what that is. So we are going to end up with 3 times 180, so that's 540 divided by 2. Okay, so we will get 270 degrees. Okay, so this is 540 divided by 2. So the answer is exactly 270 degrees. Okay, since we got a really nice answer, I wouldn't worry about the decimal approximation here. Okay, all right, so these are actually parts A and B. These are two biggie angles. Pi over 6 being equivalent to 30 degrees and 3 pi over 2 being equivalent to 270 degrees. Those are really important. These are actually angles on the unit circle. Okay, I keep hinting to this unit circle. We're getting there. Okay, so you will see these particular two angles again and again. Okay, let's move on to part C. So now we're going to take negative 7 pi over 4 radians, convert it over to degrees. Okay, so same thing, we're going to take negative 7 pi over 4 radians, and we're going to multiply it by the conversion factor, which is 180 degrees over pi radians. Okay, so the radians will cancel. You have radians in the top and in the bottom. The pi's will cancel. You'll get pi in the top, pi in the bottom. Okay, so for this particular example, okay, multiply your fractions, multiply across the top and across the bottom. This is going to be negative 7 times 180 degrees over 4, because everything in this denominator canceled, so it's just left with 1. 4 times 1 is 4. Okay, so let's go to our calculator. We're going to do negative 7 times 180, okay, and then divide that by 4. Okay, so this is going to give us negative 315 degrees. Okay, remember, if you have a negative angle in radians, it's going to stay negative if you convert it to degrees. Okay, all right, so part D. Now we've got positive 7 pi over 3 radians. Okay, again, just plug in your conversion factor here. Okay, so we've got 7 pi over 3 radians. Okay, we're going to multiply this by the conversion factor, 180 degrees over pi radians. Okay, radians in the top, radians in the bottom, they cancel. You've got pi in the top, pi in the bottom, they cancel. Okay, multiply your fractions across the top and across the bottom. This is going to give us 7 times 180 degrees divided by 3. Okay, so it's very similar to the last problem. Okay, so let's go figure this out. Okay, so we're going to have 7 times 180 divided by 3. Okay, this is going to be 420 degrees. Okay, so 7 pi over 3 radians is equivalent to 420 degrees. Okay, all right, so there we go. I'm just checking myself. Okay, so yeah, A, B, C, and D have come out really nice numbers, so I haven't bothered with the decimal approximations. That will be a different story in part E. Okay, in part E, you have 3 radians. Okay, there's no pi here. Okay, if you have a radian measure, there doesn't have to be a pi. Usually there will be a pi involved, but not always. It's okay to have 3 radians. Okay. All right, you're still going to do this the same way. Okay, if you have 3 radians, you need to multiply it by the conversion factor, which is 180 degrees over pi radians. Okay, so then same thing. Radians cancel. You have 1 in the top and 1 in the bottom, but the pi's don't cancel here because the 3 did not come with a pi. Okay, the number 3 is different than the number 3 times pi. Okay, so we are going to multiply, okay, like normal. Okay, 3 is over 1, so just multiply across the top and across the bottom. This is going to be 3 times 180 degrees divided by 1 times pi, which is just pi. Okay, if we go to the calculator here, okay, this is going to be 3 times 180 divided by pi. Okay, and here it comes. Okay, this is going to be our degree measure. Okay, 3 radians is the same thing as just over or just almost 172 degrees. Okay, we were told to round to 2 places after the decimal point here. So two places after, you have 0.88. There's a 7 that comes after, so we need to bump this up to 0.89. Okay, so this is going to be, I'm going to go ahead and put the approximately here. Okay, because we're going to round at this point. Okay, so actually, let me do this. Let me do this. Let me give you an exact answer first. Okay, if you do 3 times 180, that is 540 divided by pi. Okay, that's how many degrees this is. Okay, notice I put the whole entire quantity, the number here, the actual number of degrees is 540 divided by pi. Okay, so I didn't just put the degree symbol with the 540 because the actual number of degrees is 540 divided by pi. So I put the number part in parentheses and said all of that is degrees. Okay, and then the approximation is going to be 171.89 degrees. Okay. All right, so that was some practice converting from radians to degrees. We've already practiced converting degrees to radians. And if you look at the top of the next page, okay, if you look at the top of the next page, what you will see is a table that gives you degree and radian measures for some very common angles. Okay, so what you have here, there's actually two different tables, and across the top lines of both, you've got degree angles. Okay, so these are angles measured in degrees. And then in the bottom, they've been converted, those degree measures have been converted over to radians. Okay, these are super important. Okay, you probably want to memorize these. Why? Because these are the angles on the unit circle. Okay, these are the unit circle angles. And I know we haven't even developed the unit circle yet, okay, but I'm giving you a preview of what's coming, okay? The unit circle is a big circle with a bunch of angles, and you need to know this inside and out, okay? The specific angles on there, both in degree measurement and in radian measurement, okay? So these are the unit circle angles, okay? You need to get to a point in time where if I ask you about 135 degrees, you know it's the same thing as 3 pi over 4, okay? Or if I ask you about 4 pi over 3, you know it's the same thing as 240 degrees, okay? So, I didn't want to spend the time going through each one of these degree angles and converting them to radians or vice versa, taking each of the radian measures and converting it to degrees. That's kind of boring, and that's an exercise that, like, if you wanted to do yourself, then you definitely could. Okay, you're just multiplying by the appropriate conversion factor. Okay, but again, you need to know these specific angles inside and out, because these are the guys appearing on the unit circle, and we will start building that soon. Okay,